So there are three issues I want to talk about. The first use of the word structure is here. Structure is retained on theory change even when ontology is not. That view is called, the view associated with that claim, vague as it is called structuralism. Then there's this idea of structuralism in a completely different context, which is just something to do with the individual entities in some domain depending on each other for their existence in some way, or depending on each other for their individuation. They're only having relational properties, these kinds of ideas. And then there's this more specific issue about the status of the principle of the identity of indiscernibles in relation to non-relativistic many-particle quantum mechanics. And I'm going to talk mostly about these two. But go the right way. Do those have anything to do with each other? So here's Carl Stanford in a review of the book that Barry was kindly mentioning, which is by myself and Don Ross. And he says, basically, you've got a view that trades on using the word structure in lots of different ways. So the arguments for your view amount to nothing more than a bad pun. So thanks a lot for that, Carl. So I just sort of put up the kind of objection that you may have right at the beginning, and then you can make up your own minds whether that's really, really correct. Okay. So structuralism, I think, it's a sensible view. It is intelligible. It's just the idea that there's a middle ground between anti-realism and realism. The kind of anti-realist I usually have in mind is Bas van Fraassen. He says science is about empirical adequacy, and successful theories should be believed to be empirically adequate. If you're that kind of anti-realist, then you're going to think, look, all that's preserved on theory change from past theories is the relations that they attribute, the relations they describe between the phenomena. Okay, all that's preserved is the empirical substructure of the theory. Realism says something much stronger, that the entities described by our best scientific theories exist, including the unobservable ones. And structuralism is any view that, well, uses the word structure and tries to be intermediary between these two positions. So I think there are many cases where more is retained from past scientific theories than the relations between the phenomena. And structuralism is trying to capitalise on that. Okay. So it's John Worrell's fault. He uses this, I mean, it's even worse what he says, because he says form as well. What's retained is form or structure. What do we mean by that? He's talking about Fresnel to Maxwell, where Fresnel's is clearly ontologically a very different theory from Maxwell's. It's a theory of elastic solid optical ether. However, more than the empirical content is retained. There are equations that describe the behaviour of waves in the ether, which are carried over into electromagnetism. You can't construe those equations as describing empirical facts. Now, other examples I like are, say, the Poisson equation from classical gravitation, which is recovered in general relativity. You can't really think of that equation as a phenomenological law, but nonetheless it's retained. So there's more retained than the merely phenomenological. And many of the cases that I've invoked and other people talking about, including what Worrell talks about, involve mathematical equations being retained. And so it's interesting to consider, are there cases where we're not talking about retention of mathematical structure? And my favourite example at the moment to support structural realism is the theory of phlogiston, where it wasn't a mathematicized theory to start with, so you can't think of mathematical equations being retained. And it's a good example, I think, because there's clearly no such thing as phlogiston. Combustion is not the release of some principle of combustion. However, structural content is preserved. In particular, the phlogiston theory categorized three fundamental kinds of physical process that outwardly have nothing to do with each other, namely combustion, respiration, and calcination of metals, as all the same kind of process. And then the theory said, oh, and by the way, there's a reciprocal process. Now, that theory called all those kinds of process phlogistication and called the reciprocal process dephlogistication, we talk about oxidation and reduction, but nonetheless the structural content is carried over in that we still think that those different kinds of processes are all the same kind of process and there is a reciprocal. Okay, and I'm not going to say any more, but that's just kind of... Okay, so confusion, hermeneutic and otherwise. So part of the confusion is hermeneutic, because it's about trying to work out what Worrell was talking about, and part of it is just stuff that we managed to be confused about quite on our own. So Worrell says structural realism, if you see Worrell talk about this, he says, look, it's just Poincaré. That's what he says. Structuralism, Poincaré's view. That's really problematic, I think, because Poincaré is a Kantian. His views about the epistemology of science are really complex. He has some of his views are very particular to the case of geometry, and so on. Other people that get cited as structuralists are Russell and Carnap. These guys have views about structure as logical structure. It doesn't seem to have a lot to do with the case we were talking about originally of mathematical equations being retained on theory change. Then there's this big discussion of the Newman objection to Russell, and then people have made the connection between Worrell's structural realism and Ramseyan stroke Kantian humility, whether these are different things. But both have in common some idea about a fundamental epistemic limit to our knowledge of the world. And the connection with structural realism is something like, okay, we can only know structure. Right? There's more out there, but we don't know about it. So this is a humility that's forced upon us. We're not particularly humble or in our book. So we say no, you mustn't have a philosophy that supposes that there are unknowable intrinsic natures. That's sort of ideologically bad, we don't like it. And the whole debate about structural realism is then divided between people who I call epistemic structural realists, so people who explicate the view in terms of some epistemological limit on what we can know, versus ontic structural realism, which I use the term just to mean anybody who thinks that the view has some metaphysical content, it's something to do with rebalancing our ontology somehow in favour of structure relations as against individuals' properties. And that's very vague, but that's fine, right? Because Worrell's original view didn't say anything like that, so you can at least bifurcate the ways of developing structural realism by that distinction, even if it's a vague one, right? And then within that ontic structural realist view, there are all sorts of possibilities you can have. There are no individuals. Individuals are just structure. Individuals and structures are ontologically on a par rather than structure being ontologically secondary. There's all sorts of possibilities. Okay, but I'm not going to talk any more about those generalities. I just thought it would be sort of unfair not to mention them, so that if you wanted to argue with me about them, I wouldn't have appeared to disown myself from all the crazy stuff I said before that you might have heard me talk about or read. So when I originally read Worrell's paper, I connected it with this kind of thought of Max Planck. I didn't think about it in terms of epistemic limitation on what we could know. I thought about it in terms of mathematical representation of the world in physics is ineliminable, but we don't seem to have the resources to translate our mathematical representations into representations in terms of the standard ontology that people talk about, individuals, properties, relations, and so on. So it's also striking that in the case of quantum mechanics, there's many of the kinds of examples that one wants to give as a structural realism can be found in that case. So great structural continuity with classical mechanics. And I also made something of the fact that in the original development of quantum mechanics, it's reasonable to tell the story something like this, that when people realised that the Schrödinger picture and the Heisenberg picture were mathematically equivalent, they abstracted and ascended to the level of the structure they had in common.